Fine. So first question we are going to try is from 2010, and the questions we are going to try during this session, it's going to be based on these things. Now the equations we learned last week, I equals Q over T, if not Q equals IT, electric charge equal to current into time, and then the transportation equation, I equals in A V D E, electron density, cross-sectional area, drift velocity of electrons, and charge of electrons. That is the equation for current. And we learned something called current density, that is current divided by cross-sectional area. And then we learned about resistance. Resistance depends on rho L A, resistivity, length, and area. And then we learned about the relationship between resistance and temperature, that is resistance of a conductor at theta degree Celsius is equal to resistance at 0 degree Celsius into 1 plus alpha theta. Theta is the temperature, and alpha is the temperature coefficient of resistance. So this session is going to be based on these parts. First question: a coil made of platinum wire has resistance of 50 ohms at 0 degrees Celsius. So according to the question, R naught is 50. R naught is 50. When immersed in melting lead, the resistance of the coil increases to 115. So let's say that let's take it as R theta. We don't know that temperature. It's 115. Okay, done. If the temperature coefficient of resistivity of platinum is 4 into 10 to the power minus 3, so alpha is given as 4 into 10 to the power minus 3. The question is, what is the melting point of lead? So they're asking for theta. That's it. Very simple, very straightforward. All you need to remember is that equation. So if you can remember this equation, this question is just a piece of cake. Right, for R theta you will put 115, for R naught you will put 50, 1 plus 4 into 10 to the power minus 3 theta. And this 50 goes to the other side. I think it will be 2.3 equals, yeah, okay, 2.3. How do I know it's 2.3? Either side I multiplied by 2. So 230, 100 here. 230 over 100 is 2.3. 1 plus 4 into 10 to the power minus 3 theta. And then you can subtract this 1 from 2.3, that is 1.3 equals 4 into 10 to the power minus 3 theta. 10 to the power minus 3 is divided by 1000, it goes to the other side, becomes 1300. You need to divide by 4 equal to theta. That means the final answer, theta is equal to, in 1200 there are 300 force, extra 100 there are 25, so it's 325 degrees Celsius. You can do your math in your own way, and that is the answer. So the answer for this is second one. Very straightforward. Second one. Okay, 2010 for you, done. And then moving on, next one. Right, so next question is probably about the transportation equation, because I can see they are asking for the drift velocity of electrons. Right, let's quickly have a look at it. A uniform copper wire of cross-sectional area 10 to the power minus 7 meters squared carries a current of 1.6 ampere. If 1.6 ampere, so we normally mark all this information here itself, it's easier for us. Cross-sectional area 10 to the power minus 7 meters squared. So this information is about capital A, cross-sectional area. Right, so this is our capital A. And the current of 1.6 into 10 to the 1.6 ampere, so that is our I. Done. If there are 10 to the power 29 free electrons in 1 meter cube of copper, this entire thing is who? That is our N. Electron density, number of electrons per unit volume, that is N. The drift velocity of electrons. So they are asking for the drift velocity of electrons. They are looking, they are asking us to find out VD. We have to find out VD. I don't put V because V normally stands for voltage. It's better to put this subscribe sign because it will be easy for us to understand. And then they have given us simple E here, no? Magnitude of charge of electron, magnitude of the charge of an electron, that is a simple E. Right, we have everything we need, so it's about just substituting values and getting the answer. Another very simple question, I equals NA VD E. I is 1.6, N is 10 to the power 29, A is 10 to the power minus 7 into drift velocity. We have to find it, we don't know what that is. into 1.6 into 10 to the power minus 19. Done. Okay, so a lot of simplifications can be done. This 1.6 and 1.6 can be cancelled out, both of them. And on the left side we will have on the left side we have only 1, on the right side Vd into 10 to the power 29, here 10 to the power minus 7 minus 19 minus 26. So it is 10 to the power 3, isn't it? 10 to the power 3. Vd is equal to 1 into 10 to the power minus 3 meters per second. That is the final answer. But if you notice, all the answers are in millimeters per second. Therefore, Vd is equal to 1 into 10 to the power minus 3 is 1 millimeter. So 1 millimeter per second. 1 millimeter per second. I mean, this entire thing is 10 to the power minus 3 into meter is this millimeter part. No? Millimeter. Okay, so the answer for that is first. No issues there also. You have to be a little careful with first and fourth answers, because there's only a decimal place of difference of a decimal place. So you have to handle it carefully. You have to work with the 10 to the powers also carefully. That's it. Simple. Done. Then we'll move on to the next one. I know I'm going a little fast because we have to get rid of these things, finish it off quick as soon as possible and move on. Next one, question number 3 and from 2012, right? Two copper wires have the same volume. Two copper wires have the same volume, okay. But wire 2 is 20% longer than wire 1. The ratio resistance of wire 2 over resistance of wire 1. Right, now let's extract information here, people. So two copper wires have same volume. Meaning of that is volume of copper wire 1 is equal to volume of copper wire 2. They both have equal volume. But wire 2 is 20% longer than wire 1. This is interesting. So wire 2 is 20% longer than wire 1 means L2 over L1, okay, L2 over L1. If you take L1 to be 100%, L2 is going to be 120%. That is the meaning of 20% higher. If they had said 15% lower or 15% shorter, you will put 100 for L1 and 85 for L2. That's the way you compare percentages. Right? We have done this many times in other units also. Right, so that is L2 equals 120 over 100 is 1.2. You can say L2 is equal to 1.2 L1. L2 is equal to 1.2 L1. That's the relationship between lengths. So we don't know the relationships between areas. We can find that out. Now the question is resistance of wire 2 over resistance of wire 1. We are supposed to find R2 over R1. Two copper wires. I forgot that part. What does it tell you? When you say two copper wires, it means both of them have same resistivity. Rho 1 and rho 2 are same. Let's say they are rho. Okay, right. Two equations must be taken into consideration very quickly. One is the volume. Yeah, volume. So we know now volume of wire 1 is equal to volume of wire 2. Volume of wire 1 can be written as L1V1, L1A1 rather, L1A1, volume of wire 2, L2A2, length into cross-sectional area, Now A1 over A2, A2 over A1 is what I need. A2 over A1 is equal to, A1 over A2 is also okay, right? Let's see, A1 over A2, A1 over A2, that is equal to L2 over L1. And we already know what is L2 over L1. L2 over L1 is how much, people? L2 over L1 is 1.2. L2 over L1 is 1.2. Right? Okay. Let's quickly dive into the question. R2 over R1. That is equal to, we know R is equal to the equation which connects all these three, rho L over A. So R2 is going to be equal to rho L2 over A2. R1 is equal to rho L1 over A1. The reason I'm using rho for both is the fact that both are made of copper. So there's no point of putting rho 1 and rho 2. right? So rho and rho will get cancelled out, and we have L2 over A2 divided by L1 over A1, and we know, we have learnt in O level classes, when you have two fractions divided like that, you can write them as L2 over A2 multiplied by reciprocal of this one, A1 over A2, sorry, A1 over L1. When you divide a fraction by a fraction, you can write it this way, or you can write them as multiples, but the bottom one must be the reciprocal multiplication of reciprocal, and you can rearrange them like this. Now we will L2 over L1 into A1 over A2, that is R2 over R1. Okay, right. What is L2 over L1? L2 over L1 is this 1.2. A1 over A2 is also 1.2. Therefore, final answer R2 over R1, 1.2 into 1.12 into 12 is 144, 1.44. Right. So I'm getting fifth one. How many of you got the fifth answer? Can I see raise of hands if you don't mind? Good. So I can see a few hands going up. So I hope, right, most of you got that answer, and if you have any issues, you can ask me. Yeah, and this is a very simple question once again, people. It's just the fact that you have to consider volume, equate the volumes, and get the relationship between areas, because already they have given the relationship between lengths, and then it's a matter of just substituting the values and getting the ratio. Right, done. And let's move on to the next part now. Moving on. Okay, this one we actually did it at the class. This one, the question from 2012, I think the fourth MCQ we are going to try now. We actually did it already. But anyways, for formalities, I'll finish it off quickly. I'll take a minute and quickly finish it off. Right, what is that question? A metal wire has resistances R1 and R2 at temperatures theta 1 and theta 2 respectively. The temperature coefficient of resistivity is equal to, so we are supposed to find out who? Alpha. We have to find out who alpha is. What is alpha? Right, the equation is R theta equals R naught. R naught is the resistance of the conductor at 0 degrees Celsius, which we do not know, but that is a constant value for any for that conductor. So at R for theta 1, if I apply the equation, it's going to be R naught bracket 1 plus alpha theta 1, first equation. And for theta 2, if you apply the equation, R2 is equal to R naught times 1 plus alpha theta 2, second one. And now it's time for us to divide the second one by first one, right? Let's divide the second one by first one, so that it gives us R2 over R1. We had a problem. We had a problem when we did this. We didn't know which one is bigger, but in all the answers you can see R2 is subtracted from R1, so we have the liberty of considering that. I'll divide it the way it was supposed to be divided. This. So the reason for dividing it is to get rid of R naught. Yeah, when you divide, R naught will get cancelled off. We don't want R naught in the answer. Fine. So all we need to do is you have to make alpha the subject from this. So now a little bit of maths is going to be involved. Do a cross multiplication. R2 plus alpha R2 theta 1 R1 plus alpha R1 theta 2. And you take all the alphas to one side. I think I'll take all the alphas to left side. Alpha R2 minus theta 1 minus R1 theta 2. I'm taking alpha common, and on the right side it's R1 minus R2. The reason is R1 minus R2 is only given in the question, in the answers. Then if I make alpha the subject, it's very straightforward. What is it? R1 minus R2 divided by R2 theta 1 minus R1 theta 2. That's it. You write the equation, find a way to get rid of R naught. Simplest thing to do is divide them and make alpha the subject. Very simple. We did it at the class as well, so should not be a problem at all. Done. Two more left. Let's finish it off quickly. Right, next question is from 2013. In a piece of uniform wire, if a piece of uniform wire is stretched gradually, which of the following curves correctly indicates the variation of resistance of the length, resistance with the length L? Interesting. So what I need to do is I need to find the relationship between R and L. And the wire is if a piece of wire is stretched gradually. So let's think of that, people. When you stretch a wire like that, what will happen? Initially it will be like this, and then when you increase its length, something will reduce. What is it? The cross section area will keep reducing. No, now length is increased, as you can see. Yeah, and if you keep on doing that, cross sectional area will keep on reducing and the length will keep on increasing. This is what's happening. Agreed? So length keeps increasing, cross sectional area keeps reducing because the volume doesn't change. Total volume will not change if you don't heat it or anything. Okay, right. So total volume doesn't change, but cross sectional area reduces. When stretched, you can, this is the conclusion. When stretched, length increases and cross sectional area reduces. Okay, cross sectional area reduces, sorry. Then we'll try to figure out a relationship between R and L. That for that we have directly go for R equal rho L over A. So nothing much to do. We just have to take rho and A together like this and L. So we have a graph which has the format y equals mx. So R is going to be on y axis, L is going to be on x axis, and this is our gradient. Now obviously our answer should be either 4th or 5th. All the other answers are wrong because right, and you can't go for a y equal mx graph. That graph is not there. The reason is A reduces, no, but A reduces gradient, no? Gradient, compare the gradient is equal to rho over A. So rho over A, when length increases, area reduces. So if area is going to reduce, your gradient has to increase. Your gradient has to increase. So we are looking for a graph with increasing gradient. Therefore, what is the answer? 5th one. Gradient means the slope should keep on increasing. So as you can notice here, the slope keeps increasing. See? So slope means the angle it creates with the horizontal. Here keeps increasing. So 5th one. Okay. How many of you got this answer? 5th one. Good. Right. Okay, good. Let's move on. Done. So these questions are not very challenging, to be honest. Quite manageable, yeah. And the last one is very simple. Once again, they are asking for, this is from 2017, if I can remember right, 2017, and I couldn't see any other questions from most recent papers. So we have to do a lot in electricity. We just started the unit of current density. Now we all know the definition for current density. We learned it last week. Current density is J. J is equal to I over A. Current divided by area. Current has a unit of ampere. Area has unit of meter squared. So it is going to be ampere per meter squared. All they are testing you here is whether you know what current density is. If you know what current density is, you will quickly put the equation and get the answer. Simple. Second one. Okay, so that's it. Those are the questions we can try from MCQs with what we have covered so far.